students, today I'm going to teach you method of variation of parameter. In this video we see very important examples for exam point of view. Please watch the video till the end. So here we go with definition. Consider a linear differential equation of second order, d square y upon dx square plus a1 dy upon dx plus a2 is equal to psi of x. We'll just keep this as equation number 1, where a1 and a2 are functions of x. Then you can just see, let them give any type of equation, students. In the example, just rewrite or modify this equation in this equation number 1. Okay, suppose the complementary solution of equation 1 is, so here we always write the complementary solution. Complementary solution, I have another video. I have just made the table I have, then I have select the complementary function from that, and then I will write the solution for the complementary solution. Then we just write auxiliary equation, then we write the complementary solution. Everybody knows it, and for all the examples we have done complementary solutions many times, and in my last video and many videos I have just simplified complementary solution. So using that table, it is easy to write the solution. So we have complementary function. Here we have complementary function which is equal to c1 y1 plus c2 y2, where c1 and c2 are constants and y1 y2 are the complementary solutions of equation 1. So this is again helpful while solving the example, where we are going to use this directly and substitute the values, get the answer very easily. So after understanding what is the question given, you just simplify and just derive this method and just see how the method is being given in the form, and then we go through the various steps and remember the formulas and we solve the example, students. Okay, if this video is helpful for you in the examination, please like and subscribe my video. Yes, thank you so much. So here we start with the derivation and how the solution we are going to find the method of variable of parameter. So here we have here you can see we are going to study today method of variation of parameters. Yes, we start with the derivation. So whatever the equation they have given, I am going to implement it directly. Just adjusting the pen I have. Okay, so from equation 1 I am going to rewrite the equation and whatever I am going to solve today in method, I am going to give in the description box, so you will get the links directly. You can download it in your phone or PC and you can study the same concept. Okay, students, so we just rewrite the equation 1. So we'll just say, I will just take the y1 and two different equations. So we can just see y1 double dash is nothing but it is just d square y upon dx square. You have already gone through it. Okay, so I'm just writing directly this equation equal to 0. Just I am writing this equation in terms of y1 and y2. So here I have y2 double dash plus e1 y2 dash plus e2 y2 is equal to 0. I'm a little bit fast, and if you don't understand, just get confused, just go rewind the video once again and you will understand the steps properly. Okay, so here we have where we replace the arbitrary constants c1 and c2 present in the complementary function of function x, say a and b respectively. Therefore, so what we do here, students, whatever the complementary function we have, we get the constants c1 and c2. We just replace this by function a and b. That's it. So what is the solution we are going to get here? Yes, students, You're going to get this solution now C of, which is a complementary function y. So y is the variable. So take just y is equal to a y1 plus b y2. That's it. So this I'm going to take the solution. Is it clear? So I will just mention this as equation number 2, equation number 3, and next I am going to take this equation number 4. So all these equations I am going to use in my examples where I am directly using the solution, substituting the values. Equation 4 is very important, right? So now we will just determine the next step. Please remember, we always just go down. Yes, now I'll just differentiate this. Differentiating with respect to x, students. So you determine a and b in this process. So therefore, when we differentiate, we get y dash is equal to, now you can just see this is a into y1. Now a is also function. Replace a and b functions. So therefore I say I'm going to use u into v rule. So what is u into v rule? You know already. So I'll just write directly the answer. A y1 dash a y1 dash plus a dash y1 plus. Now in this case I will keep b as it is. Differentiate y2 dash plus differentiate b dash, and y2 remains as it is. I'll just simplify this, arrange this in a proper way, keeping a y1 dash plus b y2 dash plus a dash y1 plus b dash y2. So now we shall choose a and b such that I just choose a and b such that, so for my solution I'm just going to take the value directly. A dash, I don't want this value, so that I should get the solution. So I'll just make this as 0 and I'll keep this equation number 7. So this I'm going to use equation number 7 in my next step. When I choose this as 0, so I will get only the y dash equal to a y1 dash plus b y2 dash. So for my simplification I have just made this 0. Is it clear? Once again I will just differentiate this so that I should get the second order solution. Just differentiate this and just take again this as y double dash is equal to a, I will keep it as it is, y1 double dash plus I will just differentiate this y dash, y1 dash will remain as it is. Again I am going to use the rule u into v differentiation. So b y2 double dash plus b dash, differentiate, I will differentiate b and I will keep y2 as it is. Again, once again what I will do, I will just rearrange this y double dash e y1 double dash plus b y2 double dash plus a dash y1 dash plus b dash y2 dash. This I will keep equation number 8. Now we can see, as students, we'll simplify this. Now in this time what I will do, now I cannot make every time this 0, so this time what I will prefer to substitute or take, just directly take a dash y1 dash plus b dash y2 dash is equal to some value. I will take the function psi of x. So then, keeping this in mind, I will take this equation number 9. Now you can just see equation 6 and 9 I will get the solution. Okay, let us see now the solution here. I will take the next line, start with here. Okay, so I will just take equation 6 and 9. That implies I will get the solution, that is a dash y1 plus b dash y2 is equal to 0, what we have taken, and another value we have taken a dash y1 dash plus b dash y2 dash is equal to phi of x. This is what we have taken. Yes friends. Okay, now I want to find a dash and b dash from this. So therefore you will just simplify, or you can just directly remember. After simplification it will take a lot of time in this, and for derivation is not there in the exam, so in the solution I am just going to take a dash and b dash. So directly I am going to take or simplify, and we find a dash and b dash. We get, yes, what we get here friends, a dash is equal to minus y2 psi of x upon w, and b dash is equal to y1 psi of x upon w. Simplification, yes friends, is not important, and it will take lot of time, where we are going to choose w is nothing but y1 y2 dash minus y2 y1 dash, or just we just say simplify as y1 y2 y1 dash y2 dash. Yes, we get w in this form. So just remember this. We know that this is from Robinson's, but we don't discuss more on this. Then substituting this, yes friends, we want to find, as I said, a and b. We want to find a and b. It is in the differentiation form, where a dash and b dash, it is a function. Just I will just integrate this, integrating, and I will find a. So how I will find a, yes friends? Just I will integrate this. Minus I will take it outside. Integration y2 psi of x divided by w dx plus k1, and b I will get integration y1 psi of x divided by w dx plus k2. So therefore you can just see, substituting a and b, substituting a and b in the solution where we have taken previously, where we have taken here friends, we have taken it here. Yes, here we can see this was our solution. A and b we wanted to find, and after simplifying all the steps we have calculated and we have found out a and b. Just substitute in the solution directly, we get the equation y is equal to a y1 plus b y2 is the complete solution. Okay, let us try with the example friends. Very important example I have chosen, which may come in the exam, and here are the some steps. Before solving the example, just go to the steps. First step 1, find complementary function using the table which is given below, or it is in my last video. Just give that table in this, and find w, take y1 and y2, later differentiate y1 and y2, substitute in the w, we get the answer w using the formula. So formula I have listed, given it above the PPT. Then we can just third step, find a dash and b dash using the formula, later integrate. Yes friends, so we can just see, we have to calculate w, we have to calculate a dash b dash, and substitute in the solution. So please remember the solution friends, it is fixed. The solution is y is equal to a y1 plus b y2. If you found out a and b, that's it, this is our solution friends. So please remember this, and we'll simplify a very important example on students demand, and I came through know that This is very important. Let us try to simplify this problem, and we just see how this problem is helpful in your exam. Yes friends, how it is going to helpful, and very important that definitely this example, similar type of example will come in the examination. So let us try with the example and just see what you will get. So which question I have taken? Yes, it's a very important example, and you just see this example. Try to simplify this. Just take down the example here. First, one example I will take, solved by the method of variation of parameters. Yes, the question is given here, solve by the method of variation of parameter. Okay, so here we can see easily that the question itself says that method of variation of parameters. So I already have discussed the derivation, and already we have discussed the steps how we are going to simplify. Just follow the steps. So this is one of the question, very important, and many students have just requested me to simplify this question. On students demand, I am going to simplify. So please see that I am going to solve such examples many. But if you like and subscribe my channel Engineering Mathematics Made Easy for All, and watch the video till the end, definitely it will motivate me to make such videos, and it will be helpful in the exam. So if this video is helpful in the exam, please like and subscribe. So now we already discussed whenever method of variation of parameters are there and they give the linear differential equation. So please remember, whenever the linear differential equation, we always find out the complementary function. That is the first step. How to find the complementary function? In my previous video I have already discussed, and I will give in the description box. The notes I am going to give in the description box. Previous videos I am going to give in the description box, and I am going to give them many links, and my playlist you can just go through this, and this will come in the differential calculus, right? So this is going to help in the examination. So using the operator D, I think everybody knows how you are going to use the operator D. So I am going to take this as d square minus 1 y is equal to 2 upon 1 plus e raised to x, where please remember this students, what is d square? It is d square y upon dx square. You must be knowing this, and you have already come across this. D square is equal to d square y upon dx square. Is it clear? Okay, so let us simplify one by one. First we will try to simplify the complementary function. Without wasting the time, auxiliary equation I will write. Auxiliary equation is m square minus 1 is equal to 0. That implies m square is equal to 1. That implies m is equal to plus or minus 1. So we have discussed already that how the complementary function is being taken. Complementary function is y of c is equal to c1 e raised to x, because this is real, and real roots we have got m1 and m2 plus 1 and minus 1. So directly substitute here, plus c2 e raised to minus x. So how to find out and what is the table, I am going to give in the description box. You can just go through that and easily identify and understand how auxiliary equation is converted into complementary function. So if you simplify this, very important, that is how you're going to distribute the marks. Yes, I'm going to be very fast, and if you don't understand, just rewind the video once again, just repeat the video once again, go through the video once again. You can just rewind the video and the doubts will be clear. So in this complementary function, you can just use the table. If it is real and given distinct values, I am going to use this formula directly from the table. The table I am going to give in the description box. So this is going to become our complementary function. Please remember, always C1 and C2 are constant from the formula, but this constant is always converted in this parametric method of parametric as a and b, the functions A and B. So always I am going to directly convert this into a and b and take psi of x. So please remember how the equation is being taken. So 1 plus e raised to x. So I am going to take this as y of c or y, just take y only, so that the equation will become, or the simplification will become easier. So I'm just going to take this y only, so that it will become easier to simplify. Just and okay, sorry, here we have the pen. So y of c is equal to, this is a e raised to x plus b e raised to minus x. Yes, please go through the methods. Yes students, go through the steps. You can see the solution for this type of equation. We know that using the solution previous, that is y is equal to, we have taken a y1 plus b y2 was the solution. Please remember, I have already told you that whenever we are solving, we go through the method previous. So in the previous steps, you can see I have taken the solution. This is from that solution. Easily we can see, compare these two equations, friends. Compare these two equations. You can see a and a are same. Y is the solution. What is y1? Identify easily. It is e raised to x, and y2 is e raised to minus x. Immediately differentiate this, friends. Differentiate. We go to the step 2. Differentiate y1 dash. Please remember, differentiation is e raised to x itself. Y2 dash is equal to minus e raised to minus x. Yes students, it should be, differentiation must be easier for you all, and I believe that you are perfect in this differentiation, right? So y1 dash and y2 dash, whenever you calculate, immediately find w. What is the w given? Formula you please remember. Yes students, y1 y2 dash minus y2 y1 dash. So now substitute the values. What is y1? Yes, y1 we have y1 we have taken, e raised to x, and y2 dash minus e raised to minus x, minus y2 e raised to minus x, and y1 dash is e raised to x. Simplify this students easily. You can see minus, if I take it outside, e raised to x, e raised to minus x. So please remember this. Whenever e raised to x, e raised to minus x is there, we always take this as law of indices. X minus x, which is equal to e raised to 0, which will give you 1. Similarly in this case, you can just see it is, I am getting this as 1. So minus is there. So if you take minus, so this will give you minus. So just take this as minus 1. Similarly in this, it is e raised to minus x, e raised to x, again it is e raised to minus x plus x, which is equal to e raised to 0, which is again 1. So minus is as it is, minus I will keep it as it. This answer is 1. So directly you can calculate this as minus 2. Very easily you can find out w. Immediately find out next, I think step number 4, finding a dash and b dash. So please remember, what is a dash formula? Directly you can take it, a dash is equal to, we have taken minus y2 psi of x divided by w. Substitute the value students. What is y2? Just previously I have taken y2 as minus e raised to minus x, and psi of x we have already taken 2 divided by 1 plus e raised to x, divided by w is minus 2. So minus will get cancelled. Please see here, this minus and this minus will get cancelled. 2 and this 2 will get cancelled. So the answer you will get e raised to minus x divided by 1 plus e raised to x. Why to again keep e raised to minus x as it is? Please remember, e raised to minus x, I will write this as 1 divided by e raised to x, 1 plus e raised to x. This is our a dash. Immediately whenever you calculate the a dash, just integrate it, students. So when you integrate this, students, what you get? Yes, here we get integrating, find a Similarly, find b, substitute into solution, that is the answer. Finish. Integrating, so when you integrate these terms, I will get this as differentiation. A dash is differentiation, so integration and differentiation reverse, so I will just get a is equal to integration 1 divided by e raised to x 1 plus e raised to x, this is with respect to x, so this is I am going to take c1. We can easily see as friends, when we take the integration, we directly cannot simplify this integration, we don't have any formula for finding, so go for substitution method. In this substitution method, I'm going to take substituting or substitution method in the integration. I just substitute the value here, e raised to x is equal to t. Differentiate this, I just get e raised to x dx is equal to dt. Is it clear? Okay, these two values I am going to substitute, but here I don't have e raised to x, so I'll just take this as dx is dt upon e raised to x, but e raised to x I have taken t, so dt upon t. So all this value I am going to substitute in this integration. You may get a is equal to, yes friends, so please remember this, a is equal to, we'll get integration 1 divided by t 1 plus t into dx is dt upon t plus I am going to take the integration constant c1. Okay, I have substituted all the values. Now when you simplify this friends, I get integration 1 divided by t into t square 1 plus t dt plus c1. You can see in this case I cannot again integrate t square and into this 1 plus t. So what can I have to split this in various parts. So just go to partial fraction. I think everybody is well known with the partial fraction, and you have come across partial fraction many times. In a previous video again I have discussed the partial fraction. That link I am going to give in the description box. Even the notes, whatever is there, I am going to give in the description box. Just go through the description box notes. Okay, partial fraction, what we can take? I am going to take this inner part, that is 1 divided by t square 1 plus t. We'll just simplify very quickly. I'll just take this as a divided by t square plus split this partial fraction students. So I'm going to get this. Now find ABC. Immediately I'm going to get the partial fraction. Now I can integrate this. When we split this in 3 parts, I'm now it is easy to integrate. I'm going to find ABC. So to find ABC, I'm going to put first t value, or just simplify this. That implies this, you will get 1 is equal to a into t square is there already, so I'm just going to take 1 plus t. So b divided by t is already there, I'm just multiplied here only 1 plus t because t square is there. Here 1 t is missing, so I'm going to multiply here t, and 1 plus t I have to multiply. Here divided by 1 plus t is already there, so I have to only multiply this t square. So this is t 1 plus t and plus c, this is t square. So after simplifying this, you're going to put the value one by one. So very easily one can easily identify that t, if I put minus 1, you get cancelled. So therefore this is 1 is equal to, this is 0, a 0 plus b 0 plus c minus 1 square. That implies what is c value? So this is 1 is equal to c, or therefore we take this as c is equal to 1. So 1 value I have calculated, I am going to substitute in this. Next, what I have to put here students, so that I should get the next value. I am just thinking to put t is equal to 0. Okay, let us see. 1 is equal to a 1 plus 0 plus b, this is going to give you 0 plus c, this is again 0. Easily one can identify this, all terms will get cancelled, and a is equal to 1. I'm going to get easy. Now take, I cannot substitute more things, so I'm just going to take only the coefficient of t, only I am going to take coefficient of t. So in LHS there is no t, so I am going to take this as 0. If you multiply a into t, so a is becoming coefficient of t. Now b, if you multiply here, you can b into 1, you can say b is again coefficient of, easily one can identify 0 is equal to a plus b. That implies a is 1 already. So I mean just say this is 0 is equal to 1 plus b, or b is equal to minus 1. Just substitute all these values in this. Directly I am going to put it in the integration form. So this is going to give you 1 divided by t square plus, oh, b is minus, so I will just take minus 1 divided by t plus 1 divided by 1 plus t. So this I am going to substitute in the integration and simplify this integration quickly. Therefore I am going to get the value of a. So a is equal to integration 1 divided by t square minus 1 divided by t plus 1 divided by 1 plus t dt plus c1. So when you are going to integrate, students, so please remember the first integration I am going to simplify, and the right hand side I will just simply solve the integration of 1 divided by t square dt is equal to, I'll just say integration of t raised to minus 2 dt. You can just see this is going to give you integration minus 2 plus 1 divided by minus 2 plus 1, or simply we say t minus 1 upon minus 1, or we just say this as minus 1 divided by t. That's it. So this is simplification. I am going to get integration minus 1 divided by t minus, everybody knows what is integration of second, this is second one, integration of 1 divided by t dt. Yes friends, it is log of t. If you don't know, just go through the formula list I am going to give in the description box. Similarly, plus 1 divided by 1 plus t, 1 plus t, how we can simplify this friends? This is again, I am going to use the third law, that is integration, this is my favorite, f dash of x divided by f of x dx is equal to log of f of x plus c, whatever constant is there. You can just see, if you just take this as 1 plus t, right, I will just take this as log of 1 plus t. The denominator must be differentiation of this. So when you differentiate 1 plus t, differentiation of 1 is 0, differentiation of t is 1. So differentiation of 1 plus t must be 1. So easily you can see 1 divided by 1 plus t is always log of 1 plus t plus c. So directly I am going to take log of 1 plus t. So using this property of integration, easily one can easily take this as log of. So next is plus our integration constant c1. Now I am going to substitute what we have taken t. So let us simplify this quickly. So this will give you minus 1 upon e raised to x we have taken minus log of e raised to x plus log of 1 plus e raised to x plus c1. So this will give you, I will just simplify this once, e raised to x is in the denominator, it will take in the or numerator, it will become e raised to minus x minus log and e is always reverse to both, so it will get cancelled. I am just going to get only x plus log of 1 plus e raised to x plus c1. So this is how we have calculated a. Similarly, if you do b, substitute in the solution, that is our final answer. So let us try to find the next one, that is b. Now please remember what is the formula. Similarly, the formula for b dash, let us try for b dash. B dash is equal to y1 psi of x divided by w. We know that formula already. So substitute the value, students. What is y1? Yes, we have taken e raised to x. What is psi of x? Yes, we know that 2 divided by 1 plus e raised to, this is given in the question, directly I have taken. At w we have calculated already, it is minus. So again here you can see here 2 and this 2 will get cancelled, minus remains as it is, so I will just take this as minus e raised to x divided by 1 plus e raised to x. This is our b dash. How we can simplify? Yes, integrating. Integrate, this is easy, directly we get the solution. Integrating, b dash will become b. What is the integration? Yes friends, integration e raised to x divided by 1 plus e raised to x, sorry this is e raised to x, dx plus c 2, because c1 I have taken, so just I will take this time, c2 I will take. Okay, so let us take c2. It's 1 2 down. Okay, just okay, again I'm going to use the property, my favorite property students. What is that? Integration of f dash of x divided by f of x dx is always log of f of x plus c. Okay, now this time f of x I'm going to choose 1 plus e raised to x. F dash of x, easily differentiation of 1 is 0 and differentiation of e raised to x is e raised to x. So easily e raised to x divided by 1 plus e raised to x will give you log of 1 plus e raised to x. This formula I am going to use, therefore this is equal to minus log of 1 plus e raised to x plus c2. So therefore we have calculated b1 and b2. So we know the solution here students, y is equal to a y1 plus b y2. Substitute the values, we get the solution. Yes, what is the solution we are going to get here students? Therefore this is the final answer, that is y is equal to, I am going to substitute a value, that is minus e raised to x minus x plus log of 1 plus e raised to x plus our value, that is c1 constant. And what is y1? Yes, y1 we know it is e raised to x plus b value just now we have calculated, minus log of 1 plus e raised to x plus c2, and y2 value e raised to minus x. This is the solution students. Yes students, if this video is helpful, please like and subscribe to my channel. So here we can see easily that we have calculated the values. You can see we have done method of variation of parameters, so one can easily go through this video once again, identify. Any doubts are there, please comment on the description box, and I request everyone to subscribe my channel, and it is a free of cost video. I'm not charging anything, just go through it, practice, and all the best for the examination students. Thank you so much. It will motivate me if you just subscribe, or if you just like this video 10, I want, if you just like, and I will make some more videos tomorrow, day after tomorrow. It will be helpful in the examination. Thank you so much.